give you a heads up. We got our first laser hit. And the range was 4,638 feet.
Copy, Rick. Thanks for the
Minus
update.
7 feet per second.
Roger that.
Rick Lenahan reporting through the use of handheld laser device on board Columbia, the first visual sighting of the Hubble Space Telescope at a distance of about 4,300 feet.
Great, 15.
Go ahead.
Camaro, it's great to see an old friend, and the solar rays are nominal.
Roger that. That's great news, John.
Payload Commander John Grunsfeld reporting that the Hubble Space Telescope appears to be in excellent shape, and the solar arrays are as well. Everything poised for the capture of the telescope and the start of 5 days' worth of servicing and upgrades. This is Mission Control Houston. As you look at the very bottom of the Hubble Space Telescope at about the 6 o'clock position is the vent port through which cabling and plumbing will be snaked through in association with the installation and final hookup of the cryo cooler and the radiator lines for the near-infrared camera and multi-object spectrometer, the NICMOS instrument. That work to be undertaken by John Grunsfeld and Rick Lenahan during the 5th and final spacewalk of the mission early Friday morning.
The Shuttle 7-member crew is on an 11-day mission to repair the telescope. Well, for more on that, I'm joined now by Miles O'Brien, our space correspondent. Hi, Miles.
And good to see you. Just shy of 48 hours after the launch of the Space Shuttle Columbia, the orbiter has caught up with the Hubble Space Telescope, and for the first time in a couple of years, human eyes are taking a look at that multi-billion-dollar facility in space. You are looking straight up at the Hubble Space Telescope. That's the bottom of the $6 billion instrument. And right now, these pictures are coming down from 580 kilometers above the surface of the Earth, specifically the South Pacific. You saw the camera zoom back there, and you can see the distinct disk at the base of the Hubble Space Telescope. Right now, the astronauts aboard the Space Shuttle Columbia, 7-person crew, are within a couple of 100 feet of the Hubble. And right about this time, they might be a little bit behind their timeline, but within the next few minutes, they will creep toward the Hubble and get to within 35 feet of it. And if you'll come back to me here, I'll show you on a model exactly what's going to happen here. The Columbia will come up upon the Hubble Space Telescope, get to a point about 35 feet or 10 meters or so beneath it. That's just about the length required for the robotic arm to grab it and swing it down and put it down into a turntable type device at the aft portion of the Space Shuttle Columbia. That turntable will be where the Hubble will remain for the next 6 days during this docked series of events, which includes some 5 spacewalks. They can tilt it, they can twist it as a pair of spacewalkers, 2 pair to be exact, do these aggressive spacewalks to upgrade and retrofit the Hubble Space Telescope. Let's go back to those live pictures and give you a sense of what's going on in space. Hard to imagine this is moving. They're moving along at about 28,000 kilometers per hour right now, as they, the relative rate of motion between the two is all but nothing. What's important at this stage is, although you can't make it out, the Hubble's solar arrays, which will be replaced during the course of this mission, are put in a locked position parallel with the Hubble. And part of that, the idea there is to make sure they don't be moving around during the course of this grapple procedure, as it is called, the grabbing of the space telescope. In addition, it's important that the firing jets on the Space Shuttle Columbia that face toward the Hubble are not fired in the course of this, because it would cause some contamination to this very sensitive instrument. So those jets have been disabled, making it a little more difficult, a little more challenging for the commander, Scott Altman, to continue the maneuvers. That's, of course, something they trained for years and years, quite literally, on them, so this is not anything that's a problem. There you see, lower right-hand corner of your screen, the shuttle's robotic arm, the 15-meter robotic arm, A couple of lights. There's one at the elbow and then one right at the end. And at the end, there is a camera. That camera is basically what they call a centerline camera. And the operator of the arm, Nancy Curry, who's with the U.S. Army and a helicopter pilot, who says it's not unlike flying a helicopter, incidentally. We use that camera to line up some crosshairs, if you will, with a device that is designed to be attached to that socket, if you will, at the end of the robotic arm. We'll use those crosshairs to grapple the Hubble and then swing it around and pull it down onto that turntable. That's got to be a tense moment for anybody when you're talking about this multi-billion-dollar fragile piece of equipment. One false move and Nancy Curry will not be a very happy astronaut, and nor will NASA, for that matter.
Miles, what are the exact repairs that will be carried out once it's brought in?
Well, 5 days in all of spacewalks. This is by far the most aggressive space shuttle mission ever attempted as far as it goes to spacewalks. The first 2 spacewalks, they will replace the solar arrays. They have on board the Space Shuttle Columbia new solar arrays which are rigid as opposed to these roll-up versions which are a lot like blinds, if you will. And these rigid solar arrays, taking advantage of technology, are 20% more efficient and yet 2/3 again as large. And the reason that's important is that even though it's in weightlessness, there's drag up there, and if you reduce the size or the cross-section of items on the Space Telescope, it doesn't lose altitude as quickly. So the solar arrays are not only more powerful, but they will reduce the drag. You see that robotic arm getting ever closer to the Hubble, and when it comes time for the grapple, we'll have a daylight pass. After that, they'll begin a process where they will replace, perhaps most critically, the 3rd day, is the replacement of the power control unit on it. And it's a lot like doing a heart transplant without putting a person on a heart-lung machine. They will power down the Hubble Space Telescope for the first time since it was launched a dozen years ago. The power control unit that's on there is working fine. The concern is that the Hubble mission has been extended. It was supposed to be a 10-year mission. It's now going to last about 20 years. The concern is that power control unit might peter out eventually. So they're going to put in this new one, but there will be some very tense moments during that period of time when it is down, because no one can say for certain that when that switch goes on, it will in fact come back to life. Finally, among the other big jobs, they will be replacing some gyroscopes, which at least one gyroscope which helps point it, and they'll be putting in a camera there, the advanced camera for surveys it's called, which is 10 times more powerful than any camera that's been on Hubble heretofore. And if you think of course, this is an amazing comeback story when you think to the early days of Hubble, what a tremendous embarrassment it was to NASA in the United States when it was launched with blurry vision. It has
and the mirror wouldn't open.
Yes, well, the mirror was actually ground to the wrong angle, which is hard to imagine, you know, for something that big that that would happen. Such an embarrassment, and they were able to come back and literally fit it with prescription glasses. It has since rewritten most of the astronomy textbooks, or helped rewrite them. Now, this camera, with its 10 times greater capability, one can only guess as to what sorts of discoveries it might lead to. The bottom line is that Hubble, with its current capability, can take you back to galaxy formations, star formations, which take you back to the very earliest stages of the universe, within several hundred million years after the Big Bang. It's literally a time machine which allows scientists to really get a handle on how this universe we live in was formed.
So what happens once the repairs are done? Is it, do they use booster rockets to put it into a high orbit?
No, actually they will, if they do have enough propellant on board the shuttle, they will give it a little a boost up. But the Hubble itself, just to be clear, doesn't have its own steering rocket. So it's up there, slowly but surely dropping as time goes on. And over time, eventually, the question is going to come up, when Hubble's days are over, what is to be done with it? Because when it comes down, it will come down in an uncontrolled fashion. There's no way to guide it in, as we saw Mir come down last year. And there are many people, many scientists, who would like to see it hanging in the Smithsonian Institution, to send a shuttle up there, grab it, and bring it home. We'll see if that happens. That's an expensive exhibit, but perhaps one that people would visit.
Now, this particular mission, there was some concern earlier, in fact, a lot of concern earlier, about a problem with one of the cooling systems.
Yeah, let's go back to the model just quickly. I don't want to, these are great pictures from space, but I just want to show you quickly what was going on with that. The cooling system on any space shuttle involves Freon 21 loops. Freon is something that is we know is linked to the ozone hole. We don't use it so much, but it's a coolant that is frequently used in air conditioning systems and refrigerators over the years. It has a closed loop system which essentially goes from stem to stern on the Hubble, or excuse me, on the shuttle. And it also goes through these radiator panels which are attached to the payload bay doors, these doors right here. This one is working just fine, the starboard one or right-hand side one. This one, however, some gauges inside the cockpit told the crew that it wasn't providing the amount of flow that it would normally do in a normal circumstance. Basically, the engineers on the ground determined there probably was some blockage in an area back here and some plumbing which cools off some avionics. The question was, how serious was that blockage? It wasn't quite at the point where you declare it failed, but it wasn't optimal. So they've been running the numbers, determining what the real heat loads are, what things they can turn off to reduce the amount of heat, and they've gotten themselves comfortable with the possibility that even if the good side went down and you were left with only the degraded side, you still could safely continue the mission and you could still safely re-enter the Earth's atmosphere. However, of course, if you lost another one, they'd come home immediately. It's something that you want to have complete redundancy on. It appears we've lost the picture from Houston right now. You can take a look at the control room there as the Hubble continues its rendezvous with the Columbia, or the two of them together. There comes the picture one more time. As you can see, that robotic arm is getting very close to that grapple point, that little stanchion on the edge of the Space Telescope. This has been done now. This will be the fourth attempt at grappling the Hubble Space Telescope. You may recall the famous mission in December of '93 when astronauts went up there. It was hopelessly blurry vision on the Hubble. They were able to grab it, do a series of 5 spacewalks then, totally unprecedented at the time, and were able to correct the vision of the Hubble. Since that time, there have been 2 other repair missions, one for just to completely upgrade the telescope and add some additional equipment, and then one in December of '99, the last one, where they arrived at the telescope and it was not working at all because of gyroscopes that went down. They actually replaced all the gyroscopes at that time.
Inside 100 feet,
so this time the Hubble is working well, and as any astronaut will tell you, that puts the bar a little higher. When you go to something that works well and you're trying to improve it, you want to make sure you leave it at least in the condition it was when you got there.
Now, we can see that arm there. It looks like just a few feet away from the telescope. How does it actually connect to the Hubble telescope? Is there a hook, or is it magnetic?
Well, it's... let me see if I can try to explain it. It's got, if you, at the end, if you were to look edge-on at the end of the, that socket, it's got a series of, looks like fishing wire almost, or a little cable. And the cable can expand and contract. It's almost like the shutter of a camera. And it opens, and then when they flick a switch, it kind of snares in and shuts down like the aperture would be on a camera. And the end of it on the Hubble is just like that pen would be, and then it just grabs on, that snare comes down, and then it tightens up on it that way. That wasn't a very good description, but that's the best I can do without having a better prop. Anyway, but it's something that is a challenging thing to do because in this case, of course, Nancy Curry can see, as you can see, some sort of, perhaps a piece of space debris that flies up there toward the top of the screen. Probably nowhere near the shuttle and the Hubble, by the way. But here we go. This is the camera that is at the end of the shuttle's robotic arm, that 15-meter arm. And this camera is not just for our benefit. This is the view that Nancy Curry has helped using to get close to this point. And you'll see very shortly that attach point. And we can listen for 1 minute to Rob Navius, the Public Affairs Officer in Houston. He's doing some description.
The arm is not yet in motion. This is the motion of the orbiter still being maneuvered to the proper distance from Hubble.
Okay, as you did very obviously stated, they have the arm in the ready position, if you will. And right now, the commander of the Space Shuttle Columbia is doing the work, Scott Altman, who is literally using the steering jets of Columbia to creep along up to and
soon to come into view will be
Columbia.
The grapple fixture on the Hubble Space Telescope. The relative motion between the two vehicles at that point will be dampened out as Scott Altman puts the brakes on. And Nancy Curry then will be given the go-ahead to begin extending the arm for the actual capture of Hubble.
So what we're looking at here, Miles, is
And the grapple
actually the
fixture
whole
now
shuttle
coming
is
into
not
view at
moving
the very
towards
top
the,
of your screen.
Well,
the
yes,
Hubble.
actually the whole shuttle is right now. Here, let me give you a quick model representation of this, if you could. The arm is stiff, the Hubble is stationary relative, and just basically what you're watching is at the end of that arm, the picture of the Hubble passing by as she gets to that point where she's level. Now you see that disc there,
Hubble,
that white
directly over
disc
the
in the
payload bay
top
of Columbia,
center of your
precise
screen.
flying being,
That's her target.
conducted
That's what
by
she's
Commander
going after
Scott
right there.
Altman
That
from
is
the
the
aft flight deck
capture
of the
point.
orbiter.
And as that becomes level with her position, Scott Altman, as Rob Navius put it, will put on the brakes. Of course, there aren't any brakes in the shuttle. He'll use his steering jets to slow down that relative rate. The idea is to get the relative rate between the two vehicles, Hubble and Shuttle, relatively speaking, they should be stationary. And then at that point, she can begin the process of bringing that robotic arm in and performing this capture. I mean, this is something they do for hours and hours in simulations in Houston. And what they tell me to a person is that the real thing, and this is a testament to the kind of training they do, the real thing is usually easier because it's very difficult to simulate the benefits, if you will, of being in zero gravity on the ground in Houston.
They probably use the worst case scenario, don't they?
Well, they do enjoy doing that, as the astronauts say that you know, they have these missions where things go well and they come back and they say all that good training wasted once again.
But still, I mean, you have the shuttle and the Hubble, which, as you mentioned, are moving at phenomenal speeds right now.
Yeah, about 28,000 kilometers per hour.
So it must require some dexterity to pull that down.
Well, yes. I mean, we're talking about some hand-eye coordination, but after all, Scott Altman is a Navy test pilot who cut his teeth flying F-14s and F-18s for the Navy and did a lot of the stunt flying for the movie Top Gun. So he's a man who knows a little bit about which way to move a stick and rudder. And Nancy Curry is an Army aviator with tremendous experience in rotary aircraft, and she says this operation, which we're witnessing right now, as I believe we're watching right now the arm finally moving toward that grapple point, she said it's not unlike flying a helicopter in the sense that you have to, it's the same sort of hand-eye coordination. She's sitting at the back portion of the aft flight deck of the Space Shuttle Columbia, and she's able to look out through these top windows here, and she can see the Hubble, which right now is probably up like this as she begins the process of homing in on it. She's also using that camera, but she has a stick, not unlike the stick you'd see in an aircraft, which allows her to maneuver that arm. Of course, it's not using thrust like you would get or lift like you would on a helicopter. It's just actuators and motors. But it's the same kind of hand-eye coordination, she says, and as a result, actually flying helicopters is probably good training for this kind of thing. Now you can see as
the
she
Payload
brings it
Deployment
around,
and Retrieval Systems Officer reports that the
you can see
robot
that-
arm now in
that
motion
rod
for the
sticking
grapple
out
of
of
the
the
Hubble
middle of
Space
that
Telescope. The orbiter
disc
has been
that looks
placed
like
in
a,
free
you know,
drift to
pizza,
prevent any
pan
inadvertent jet
there.
thruster firings
And
during
that
the final capture of the
shaft
observatory.
is exactly what she's aiming for. If you look to the top, you can see that black
aligning the end
device
effector of the arm,
with the
with
white
pin on the
line
grapple
across it.
fixture that you
Looks
have
like
in
you'd
view.
see sort of an artificial horizon on an aircraft for those of you who fly out there. And that is what she uses for targeting. There's one other camera she has access to which has a similar type of depiction upon it. And if she lines up those two items together and comes straight in, now you notice, you see that in the circle there, there's a little dot in the middle. As long as that dot stays in the middle right now, she is right on target.
Curry now moving in for the grapple
If
of
that
the Hubble
dot
Space Telescope.
moves up or down, she's off center. Now she's coming in for that grapple maneuver.
Now, this is the arm that's moving.
Yes, the shuttle and the Hubble now are stationary to each other, relatively speaking. The arm is closing in on the grapple. And there's a shot from the payload bay of the Space Shuttle Columbia as it comes in. You can see it comes in very slowly, but, you know, it's still something you can detect clearly. And, you know, once again, they do make it look easy. They do train an awful lot, but you can imagine...
Columbia and Hubble over the Pacific Ocean, southwest of Mexico and Central America, standing by for capture.
All right, and there it goes. There's the shuttle's robotic arm. And let's listen for the call from the Space Shuttle Columbia.
Grapple confirmed.
Okay. Space Shuttle Columbia has successfully attached to The Hubble Space Telescope setting the stage for 6 days of docked operations, if you will, operations with the Hubble in the payload bay. The crew on board.
Hubble on arm.
Copy, Scooter. Outstanding work, and there's a big sigh of relief we heard from Goddard all the way here.
All right, just to give you a sense, that Scooter is Scott Altman, the commander, on the other end of the line. Mario Runco,
I
another
think it
astronaut.
echoed up here as well.
And Goddard is the place where the Hubble Space Telescope is flown. That's the Goddard Space Flight
Central
Center
Time
in Maryland.
over the Pacific Ocean. Using kid gloves, Nancy Curry has a firm grasp on the Hubble Space Telescope after a flawless rendezvous.
And the voice of Rod Navius, Public Affairs Officer for NASA in Houston, confirming what we just saw. Once again, they make it look effortless on it.
It looked like it, yeah.
It's difficult to get a sense of the speed and the remoteness of what we just witnessed live.
Yeah, it looked almost static when you looked at that arm going down there. Now, Miles, how long is it going to take for them to bring that Hubble down onto the payload floor?
It's going to be going on right now. Within the next hour's time, we'll begin the birthing.
Well, the next major activity, of course, is to move the telescope aft with respect to the orbiter and get it lined up over the FSS and get it berthed. That probably would take anywhere from 45 minutes to an hour. We'll
just answered our
probably watch her hold the telescope here for a few minutes just to get the solar rays and everything stabilized. The solar rays are really the part of the telescope that you're most concerned about as you begin to maneuver it. One of the advantages of the new arrays that we'll be installing over the next several days is that they're far more rigid, and it won't be quite as necessary for us to be as careful with them as we are with the ones currently on the telescope. In fact, on the television view now, you can see the arrays wobbling just a bit. She'll keep an eye on that as she maneuvers the telescope very slowly back for its cradle.
Now, I should tell you who that is you're listening to. That is the voice of astronaut Steve Hawley, who was the man who was controlling the robotic arm back in 1990 when the Hubble was deployed. Of course, that was before anybody realized that the Hubble was born with myopic vision, and it was a high moment for the scientists at that time. It wasn't until much later that they realized they had a big problem. It's an incredible roller coaster ride, this Hubble Space Telescope. It's been a story of tremendous embarrassment and tremendous success as well. And it remains to be seen what the next 6 days will be, what part of the chapter, what part of the roller coaster ride it will be, but we'll be watching it all on the way, Anna.
No doubt. Miles O'Brien, space correspondent, thanks for coming in. And, well, as we can see, the arm is connected, and no doubt we'll be following this closely in the hours ahead. Thank you.
Thank you.
And we have breaking news now from the Middle East. 3 Israeli Apache helicopters have staged strikes close to Yasser Arafat's headquarters in the West Bank city of Ramallah. The strikes follow a day of escalating violence in the Middle East that began Saturday with a suicide bombing that killed 9 people in Jerusalem. At least 9 Israelis, including 6 soldiers, were also killed in one of 2 shooting attacks that followed. So the latest there, 3 Israeli Apache helicopters are staging strikes close to Yasser Arafat's Ramallah headquarters. More on that and other news coming up in just over 25 minutes on World News. But for now, we're going to return to scheduled programming. I'm Anand Naidu, and you're watching CNN.
This has been a CNN live event.
This view as the orbiter is being maneuvered again within striking distance of the Hubble Space Telescope. You're looking at the slot in which the wide field planetary camera is located. The arm is not yet in motion. This is the motion of the orbiter still being maneuvered to the proper distance from Hubble. The Payload Deployment and Retrieval Systems Officer reports that the robot arm now in motion for the grapple of the Hubble Space Telescope. The orbiter has been placed in free drift to prevent any inadvertent jet thruster firings during the final capture of the observatory. Curry now aligning the end effector of the arm with the pin on the grapple fixture that you have in view. Curry now moving in for the grapple of the Hubble Space Telescope. Columbia and Hubble over the Pacific Ocean, southwest of Mexico and Central America, standing by for capture. Grapple confirmed.
Houston, we have Hubble on the arm.
Copy, Scooter. Outstanding work, and there's a big sigh of relief we heard from Goddard all the way here.
I think it echoed up here as well.
And the robot arm officer here in Mission Control reports that Nancy Curry has begun to move the remote manipulator system and the Hubble Space Telescope back from its capture position towards the rear of the cargo bay of Columbia in preparation for the actual berthing of the telescope on the flight support system. Sunrise over the Hubble Space Telescope, illuminating the golden solar arrays. Those arrays to be retracted for the final time a few hours from now. They will be replaced by new rigid solar arrays, 1/3 the size of the ones you're looking at, which actually will be blue in color. The cells are made of gallium arsenide on the brand new solar arrays to be installed tomorrow morning and Tuesday morning by 2 teams of spacewalkers.
Camera D on monitor 2 is zoomed in now, and you can just see a little bit of it there. I think we're going to lose it as the sun comes up.
Copy that. We have a good picture, and we did see a few particles there. And Scooter, clarification, is this what sometimes we see off the engine bells, the flaking of the ice that seems to happen sometimes for days at a time?
The lower portion of the telescope, you can barely make out the dark oval-shaped objects on the aft shroud of the telescope. Those are actually the fixed head star trackers, and right above it, that rectangular lighter colored insert is the wide field planetary camera 2, which soon will be joined by a new astronomical observation instrument, the advanced camera for surveys, which will be installed to replace the faint object camera in the telescope. The advanced camera for surveys to be installed on the 4th spacewalk by Jim Newman and Mike Massimino early Thursday morning. This is Mission Control Houston. Again, a good view looking right up at the bottom of the Hubble Space Telescope as Nancy Curry prepares to begin the series of procedures to slowly but surely lower it down onto its berthing platform at the rear of Columbia's cargo bay. In this view, in the upper left-hand portion of your picture, is the vent port on the bottom of the telescope through which the cabling and plumbing lines will be snaked through by astronauts John Grunsfeld and Rick Linehan on Friday during the 5th spacewalk of the mission.
Houston, Columbia for HST.
Go ahead.
For HST and payloads, the berthing latch operations are complete.
Copy that and concur. Good work, gentlemen, ladies.
And at 4:33 a.m. Central Time, with Columbia sailing high over the southern Indian Ocean, the Hubble Space Telescope now securely latched onto its berthing platform, ready for its servicing over the next 5 days of spacewalks.
And Houston, Columbia, are y'all getting the flight deck video?
That's affirmative.
This is a videotape replay of activity that took place earlier this morning during Columbia's rendezvous to the Hubble Space Telescope. Commander Scott Altman in the field of view right now with Nancy Curry directly behind him and pilot Dwayne Carey on the right. This videotape replay of flight deck activities during the rendezvous of Columbia to the Hubble Space Telescope, showing Nancy Curry and Mike Massimino at the aft flight deck, Dwayne Carey sitting in the commander's seat, Columbia's pilot checking all of Columbia's systems and providing range and rate closure for Commander Scott Altman, who manually flew Columbia.
The Hubble telescope is now held in the arm of the U.S. Space Shuttle Columbia. The telescope is set to undergo a 6-day makeover by the 7-member crew. CNN space correspondent Miles O'Brien joins me now again with the latest on what's happening. Miles, the last time we talked, it was heading for the Lazy Susan, right?
We have arrived at the Lazy Susan, to use the non-NASA term, but you know, a term that works very well. Lazy Susan is exactly what it is. It allows the Hubble, once it is attached to it, to be spun around and tilted a little bit, so the spacewalkers, 2 pairs of them during the course of this mission, can work a little easier around it. Let's look at some live pictures which are coming down from the Space Shuttle Columbia right now as it travels overhead 580 kilometers above us, 28,000 kilometers per hour. This is a shot from the end of the robotic arm. By the way, that's the sunrise or sunset, I'm not sure which, just over the limb of the Earth. This camera right here is part of the so-called star tracking system, which allows Hubble to find out where it is in the universe, if you will, and allows it to point more accurately at its ultimately at its targets. This thing that is a white box here, which looks like it slides in like a drawer, does in fact slide in like a drawer. That's the Wide Field and Planetary Camera 2. It will be changed out during this mission. Take that back. The faint object camera will be changed out to make way for the advanced camera for surveys, similar drawer-like object to that one, and that is a camera with tremendous capability. You got to remember the Hubble was designed in the 70s, launched in 1990, and as time has gone on, technology has improved, and so has the capability of these CCDs, the charge-coupled devices, which allow for better imaging of distant objects, and that is, of course, what the Hubble is all about. This is more of the star tracking capability. Inside of those shutters are some of the cameras which point and identify specific stars and allow the Hubble to home in, if you will, on what it needs to see. What we're watching here is a survey of the camera. Engineers and scientists right now at the Goddard Space Flight Center in Maryland, where the Hubble is flown, are looking at this very carefully as Nancy Curry, the shuttle astronaut, moves the robotic arm, the 15-meter robotic arm of the Space Shuttle Columbia very slowly, inch by inch over the surface of the Hubble. What they're looking for is how it's doing. Last time they saw it was December of 1999. There are tremendous temperature swings that it encounters during every orbit, and certainly micrometeoroid problems that can crop up, little dings. This could be one of those dings, possibly caused by a small piece of space debris, either natural or man-made. These yellow handles here, those are astronaut handholds. Those were designed to make it easier for the Space Shuttle astronauts when they come to repair the Hubble to move around on the outside of it. Anything that's yellow, they know they can touch without causing any great difficulty to the very sensitive instrument. That's important because you don't want to be pulling on the wrong things. And there, right up there, is yet another grapple target, the same kind of target. As a matter of fact, that probably is the target that was used by Nancy Currie to attach to the Hubble and put it down in the Lazy Susan, as we call it. Let's look at the pictures which came down about 2 hours ago as the Space Shuttle and the Hubble met. That is the robotic arm as it attached to that point. I just saw you. It looked like that pizza pan, and on it is that shaft which protrudes out there. That's exactly the target that the arm is aiming for. And Nancy Currie proved that all that astronaut training in Houston pays off well. She homed in on it. She used this target. As long as she keeps that little dot inside the circle, the dot is a little bit closer to us than the circle. As long as she keeps that in place, she's flying right down the chute, if you will, on final approach to the Hubble. She did it well within the margins and made it look effortless. So let me just show you on the model exactly where things are and how things will kind of occur in space. The Hubble will sit, as we told, as Anna mentioned, in a kind of a Lazy Susan device which spins around, allows the astronauts to reach the various bays that they need to reach in order to do their work. One of them typically will be riding at the end of the robotic arm, and the other will be a free floater tethered at all times as they do their work. They'll change out the solar arrays, a power control unit, which is kind of a risky move. They'll shut down the Hubble for a little while to do that. They'll put in that advanced camera for surveys, 10 times more powerful, replace a gyroscope, and do a few other housekeeping items, including resuscitating an old instrument, an old infrared instrument, which is no longer working because its cooling system has gone kaput. They'll put a new one on there. And when they leave, they hope that they will leave a much stronger, more capable Hubble, which has about 8 years left in its mission. Anna?
Thank you, Miles O'Brien, for bringing us up to date there.
You've been an ASIC.
It was handed over to us.
Crew members on the U.S. Space Shuttle Columbia are preparing to start repairs on a giant space telescope.
Grapple confirmed.
Columbia hooked onto the Hubble about 3 hours ago. The crew is on an 11-day mission to replace Hubble's power control unit and steering mechanism. And they'll also install a powerful new camera. Miles O'Brien is following the mission.
They'll come out each day for 5 days, 6.5 to, who knows, maybe 8-hour spacewalks. And they'll use, working in tandem, one of the spacewalkers will be working at the end of this robotic arm, this 15-meter robotic arm. Hopefully the Hubble won't tilt like that while they're up there. And the other one will be more or less a free floater. And they will go in and around and actually get inside the Hubble on occasions to do what they have to do.
NASA allowed the repair job to proceed despite a slight mechanical problem that engineers say is not threatening to the mission.
Die US-Raumfähre Columbia hat heute erfolgreich an das Weltraumteleskop Hubble angedockt. In einer 11-tägigen Mission sollen Astronauten das Teleskop modernisieren und eine defekte Infrarotkamera austauschen. Technische Probleme mit dem Kühlsystem der Columbia hatten die Fortsetzung des Einsatzes bis zur letzten Minute in Frage gestellt. Die NASA geht aber davon aus, dass die Wartungsarbeiten ohne weitere Vorfälle abgeschlossen werden können.
Columbia fängt Hubble ein. Die Besatzung der US-Raumfähre hat nach einer 2-tägigen Verfolgungsjagd im All das Weltraumteleskop Hubble am Shuttle festgemacht. Damit ist der schwierigste Teil der Mission bereits geschafft. Das altersschwache Teleskop soll auf den neuesten technischen Stand gebracht werden. Der erste von 5 Weltraumspaziergängen ist für morgen geplant.
The shuttle rendezvoused with the Hubble telescope more than 500 kilometers above the Pacific Ocean.
Grapple confirmed.
NASA says it's one of the most delicate and challenging missions the shuttle has ever undertaken. To underline the point, ground control woke up the astronauts with the theme tune from the television series Mission Impossible. The decision by the controllers to continue Columbia's mission despite the coolant problems means that astronauts will begin fitting new equipment and parts on the Hubble on Monday.
We're going to do our job, and we've just kind of kept that thought foremost in our minds. There's been so much to do to get ready for the spacewalks, the rendezvous and the spacewalks, that we've just kept ourselves busy and tried not to think about it since we don't have much control over it.
The astronauts will perform 5 spacewalks to give the telescope a major refit to improve its performance massively. For 12 years now, the Hubble has been sending back unprecedented pictures from deep space. Now, astronauts will fit, among other things, a new power control unit, a more reliable steering mechanism, and a new camera, which NASA says will make the Hubble perform 10 times better. David Chazan, BBC News.
Reparaturen im All. Die US-Raumfähre Columbia hat heute Morgen erfolgreich das Weltraumteleskop Hubble eingefangen. Ein computergesteuerter Fangarm machte an dem Teleskop fest, um es in den Laderaum der Columbia zu manövrieren. Die Astronauten sollen das 12 Jahre alte Teleskop General überholen. Für 2 Tage war unklar, ob die Columbia ihre Mission erfüllen könnte. Kurz nach dem Start hatte die NASA einen Defekt im Kühlsystem gemeldet. Dieser stellte sich jedoch als harmlos heraus.
Hubble appears to be in excellent condition almost 12 years into its scientific observations. This is Mission Control Houston, a rather dramatic shot now from the elbow camera on the shuttle's remote manipulator system, looking right down at the cargo bay of the shuttle Columbia, the Hubble Space Telescope at the top of your screen, the aft shroud, as it is mounted on the flight support system berthing platform.
Columbia, Houston, it's time to hand over in the control center down here. Orbit 1 is going to pass along the activities to Orbit 2. Tony and Steve will take you the rest of the way. Good job today. You made it look easy. Keep up the great work.
Inside of your screen, you can see the 180 number beginning to rotate as the Hubble Space Telescope is moved very slowly into a position that will allow the crew to watch the starboard solar array retract. This right-hand view being provided by a camera in the forward portion of the payload bay of Columbia, looking toward the bottom of the flight support system where the Hubble Space Telescope is mounted.
And for the rest of the crew, expect retraction command in 15 seconds.
And we are seeing motion in the starboard solar array.
Columbia, we see good motion.
Copy, so do we.
Starboard solar array beginning to retract. Both ends of the starboard solar array being retracted into the center section of that array. Retraction of the 2 solar arrays is necessary in order to remove them and replace them with new solar arrays, and those old solar arrays will be brought home for study. Starboard solar array seen here on the top of your screen, continuing to retract.
Houston, Columbia for pilots, 4 spas remaining.
Copy.
This is Mission Control Houston getting another view on our split screen, looking at the center portion of the starboard solar array of the Hubble Space Telescope as it is retracted. The starboard solar array is facing the forward portion of the payload bay of Columbia, which allows the crew on the flight deck to monitor all the movements.
Houston, Columbia, 3 spas remaining, nominal.
Copy.
Starboard solar array continuing to retract as it should. There was an initial glitch and the first command did not cause the starboard array to retract. System was reset and the second command did the trick. Starboard solar array continuing to retract. This view provided by the shuttle's robotic arm, a camera on the end of that robotic arm.
Houston, Columbia, 2 spas remaining, nominal.
Copy, and we have a great view on the big screen.
In this view you can see the starboard solar array of the Hubble Space Telescope as it's retracting. Columbia currently flying over the central Atlantic Ocean between South America and Africa.
Columbia at an altitude of 350 statute miles as we watch the Hubble Space Telescope's starboard solar array retract into itself. All of this in preparation for the eventual removal of that solar array and replacement with the new solar array. The new solar arrays are rigid and don't retract like these do here. They're about 1/3 the size, but will produce 20% more power. The first of those solar arrays will be put on the Hubble Space Telescope tomorrow morning, and the second one will be done during a spacewalk on Tuesday.
For the mail sync, if you guys could, we'd like you to close Outlook. Columbia, Houston, retraction command in 15 seconds.
Okay, we're standing by.
This is Mission Control Houston. The port solar array has begun to retract. This view of the port solar array being provided by a camera on the end of the shuttle's robotic arm, looking down toward the port solar array. Hubble Space Telescope at the top of your screen.
Columbia, Houston, you should see stow on both microswitches.
Yes, we do.
And we got a winner on both sides.
Well, good morning, everybody, and welcome to today's mission status briefing, updating the progress of Columbia's voyage to the Hubble Space Telescope for this 4th servicing mission. I'll introduce the panel this morning. They'll each have some comments, and then, as usual, we'll throw it open for questions. To my right is Wayne Hale, who is the Mission Operations Representative for STS-109. To his right is Brian Austin. He's the lead flight director for this servicing mission to the telescope. And to his right is Preston Birch, who is the Goddard Space Flight Center Hubble Space Telescope Program Manager. Again, we'll hear from all three, and then we'll take questions. And with that, I'll turn it over to Wayne.
Well, good morning, everyone. It is a great day in space. We have the Hubble Space Telescope, which is probably the premier scientific instrument of our generation, berthed in the Shuttle payload bay, ready to be refurbished and renewed, and then 5 or 6 days sent back out to uncover more and exciting things about our universe. We have had a great flight so far. Everything today has gone just exceedingly well, and the team that planned this mission and put all the procedures in place deserves to be congratulated for how far we've come. And yet, again, when we think about it, the real work is going to start tomorrow. And I'm going to turn it over to Brian Austin, the lead flight director, who's going to tell you a lot about that.
Thanks, Wayne. As you mentioned, a great flight to this point. The rendezvous today went very smooth. By the book, our procedures that we laid out, very typical of a rendezvous day. We started off very early in the crew's day into the rendezvous activities, primarily to give us some time on the back end of the day to retract the solar rays, which you saw went very well. Again, a very nominal rendezvous from the crew. Grappled the telescope as you saw that final creep up through the approach of the telescope, and finally grappling, and everything went well. It's a very, very slow and paced time period at that end. We gave us about an hour from the time we grappled at the time we latched and mated the telescope to the orbiter. Transferred the power onto the orbiter, so the telescope is now powered through the orbiter and will be that way through the large part of the berth mission. Again, everything's working fine. We're not really working any issues with the orbiter. Tomorrow's activities, as you know, start off our round of 5 EVAs. We look to be going out the door. Egress is around 12:30 in the night. I really expect the crew to be pushing to go out a little early, as we're planning to try to do each day to get out the door up to maybe an hour early, maybe 30 to 45 minutes or so, just to get things going and give us some opportunities on the back side of the day if we need to finish up our activities. But again, very good day, and looking forward to really a start of an exciting servicing mission tomorrow. And Preston, the opportunity to elaborate on today's work.
Okay, thank you, Brian. Well, speaking for the HST program, we're very glad to be aboard Columbia with the observatory, and we're off to a really great start for this mission. It's always a very exciting time for us on the ground to see Hubble come into view from out in the distance, and as we approach it, to see the increasing level of detail that comes into view. And of course, we're always very interested in knowing how it's fared over the last few years since it was serviced the last time. And I can say right now that Hubble is in excellent shape. Our initial examination of the exterior of the observatory does not indicate any significant or noticeable changes since December of '99 when it was serviced last. Admittedly, we've only seen approximately half of the exterior of the observatory, and we have not had an opportunity to look at it with a lot of precision or high resolution, and we will be doing that over the next few days. But there are no significant changes that we've been able to detect. All of our HST operations went extremely smoothly. We've closed the aperture door before we rendezvoused and grappled. We've retracted the high gain antennas. The solar ray retraction operation today went extremely smoothly. And all the other systems are go. The space support equipment that's located in the payload bay of Columbia has all been thoroughly checked out and is working just as we would expect it to. So right now HST is go for EVA Day 1 tomorrow, and we'll be retracting the first of the solar array wings, and we're looking forward to accomplishing all of our objectives on this mission. So we're very pleased with everything so far.
Okay, thanks, gentlemen. We're ready for questions. Frank, you got questions? We'll start up here with Frank, and then we'll go to the Kennedy Space Center in Florida, where some press are located. Go ahead, Frank.
Frank Mooring with Aviation Week. First off, has there been any change in the status of that Freon loop? Is it still doing as you expected it to do?
The Freon loop has been rock solid. We've seen it perform just the same way we have for the first 24 hours of the mission through the second 24 hours of the mission, and we don't believe that there'll be any further changes in that status, but it's doing very well.
And I noticed at the end of the day today that there was a question about some seepage from one of the fuel cells. Could you elaborate on that a little bit, and particularly what the risk is there to the suit?
Brian, you want to answer that one? You were there when it happened.
Yeah, and really, I think it's maybe overplayed a little bit. There's not anything we're really working with that. There were a couple of points that we saw. There's some check valves in the lines as the fuel cells produce water. They flow that water out a normal primary path, and there's some alternate means to relieve the water just to protect the fuel cells. And we saw, and there's check valves to protect those paths, but also to provide the pressure relief as well. And we think maybe just once or twice we saw some seepage through there, but several just discrete events, and it's nothing at this point, and everything's still working fine.
What happens if that seep water gets into the suit tank?
Well, the water, or the combination of what's in there is water plus some additional hydrogen, which is what we try to avoid, I guess, if you will, and the way we route the water in through the tanks and separate the hydrogen out through one route. And it's just something, worst case, it becomes something you just don't want to have that element of hydrogen separate and return itself to its own state inside the suit. It could be a flammability problem in a larger extent, but we're in a good configuration with the tanks and the water routing that we plan to use for the suit charging.
Anything else?
One more from me. Based on what you know now, will the arrays stow in the carrier?
I think so. I think most of our interest was in the retraction. I think that the rest of it is more of a fit check standpoint. And Chris, if you would elaborate, I think what they've had on the ground and testing the interfaces, I don't think we have any concern.
We're highly confident that the arrays will seat properly in their designated place on the carrier. Shouldn't be any issue there. We got a complete retraction on the arrays. We had some backup devices to potentially stow them if they weren't quite fully seated. We're not going to need to use those array straps, as we call them. So everything's 100% nominal in that department.
Okay, let's go down to Florida, where it may be a little bit warmer than here, and take some questions from the Kennedy Space Center. Go ahead.
This is Steve Seislaw from Florida today. I have a couple of questions for Preston. First of all, when you were choreographing these EVAs in the very beginning of this cycle, how difficult was it to plan around so that you would always leave Hubble in a deployable position at the end of each EVA?
Well, there are parts of the mission where things get a little tricky, and then there are other parts where it's not quite so challenging. The first couple of EVA days are relatively easy to cope with. The biggest challenge is the PCU day. Our goal, of course, is always to leave the observatory in a safe configuration overnight, and preferably in a condition where we could deploy it rapidly if the orbiter had to suddenly return to Earth rapidly, and we had to do a rapid deploy of the observatory. Our goal is always to leave it in a state to be rapidly deployed overnight. And the way our EVA plans are laid out, we intend to achieve that every day. Now, there are certain contingencies where that might be difficult to do, and we've examined those, and we've done a lot of things to try to mitigate the risks in those areas. But if everything goes nominally, there's no real issue there.
Okay, thanks. And During these first two spacewalks that, like you said, are relatively easy, and I realize you're going to probably lose most of your sleep on the PCU spacewalk, but what's your mental state going to be like during all of these? Are you going to be on the edge of your seat during every one of them?
Well, we don't take anything for granted. I'll tell you, there's been so much effort put into the design and development of this mission, the training and simulations and whatnot, that by the time we get to the mission, we really feel well prepared, those of us on the ground in the operations area, and we have full confidence in our EVA crew. They have worked exceedingly hard, and we've covered just about everything we could reasonably prepare for. So I don't think we're going to be really biting our fingernails. We're going to be excited, we're going to be very attentive, and we're going to be working real hard here on the ground, and in that sense there won't be much time for fretting and worrying. I think we feel very confident, but we're not overconfident. We're not taking anything for granted.
This is Marcia Dunn of the Associated Press with a few questions for Preston. It almost looked like the two solar panels were maybe somewhat warped. Did you notice that? And did you notice any possible micrometeorite hits on the panels as they were folding up?
The resolution of the television cameras is not sufficient to show any micrometeoroid impacts. They're undoubtedly there because we saw those on the one wing that was returned from servicing Mission 1 back in 1993. And we're going to be very keenly interested in looking at the arrays and examining them. You know, most engineers are naturally inquisitive, and so they want to know how they fared and how that's done. As far as the twisting that's apparent in the arrays, that is always present. That's a natural state of those arrays, of that structure. And the twist had not really changed appreciably since we deployed those arrays back in 1993. If they do twist too much, it can potentially make retraction difficult. And so we did a lot of preparation and analysis and established criteria for the crew to use in assessing the condition of the arrays before we retracted them. But that was one of the first things that we examined once we got the observatory berthed in the cargo bay or in the payload bay, and it appeared to be very nominal. There was very little or no change from what we had seen previously. But that's nominal or normal, what you saw today.
Thank you. And I'm wondering, when you caught your first glimpse of Hubble and it got closer and closer and bigger, how excited were you to see this for the first time in over 2 years? Were you with other Hubble managers and scientists? What was the mood?
Oh, everybody's always extremely excited. First of all, it's an incredibly beautiful object. It's covered with the silverized or aluminized Teflon, and there's a lot of facets to it and a lot of symmetry to it. And it's a very exciting instrument, and of course we live with it. Those of us on the HST program, and especially the operations folks, who live with it 24 hours a day, 7 days a week. And so we're always conscious of its state of health, but what you see through telemetry only tells you so much, and being able to actually visualize it and see it when you haven't seen it for a few years, of course, we always wonder what has happened to it that we can't detect in telemetry. And so it's a very exciting time for us, and we're really glad to see it again. So everybody was very, very excited and thrilled, I can tell you.
And I'm wondering, when was the last observation made before the aperture door was shut, and do you know what the target was?
Gosh, I couldn't tell you what the target was. I could find that out for you, but it was approximately 24 hours after liftoff of Columbia was when we stopped making observations and started configuring the observatory to prepare it for a rendezvous and grapple.
Thank you. That would be nice if you could find that out for me.
Okay.
And a question for one of the other two gentlemen. During some downlink videotape that the crew put down, I guess after the Hubble grab, but the video was showing what was going on in the cockpit prior to that, there seemed to be a crescent-shaped object that was seen floating out through space, sort of twisting, shining, and tumbling. And I'm wondering, do you have any idea what that was, how big it was, or how close it was to the shuttle?
It was more than likely a piece of ice, just from the non-straight, I guess if you will, just like you described it, shape. It's more than likely it's something we see early in the flight with pieces of the moisture that become formed into ice and then slowly find their way off the vehicle, either after an ohms burn or some burn, something on orbit, kind of giving the vehicle a little bit of a shake. Sometimes after we've been at night and then come into day and some of that starts to break loose. It's not uncommon. I'm pretty sure that's what it was. So it more likely came from the vehicle and just right in the vicinity and just worked its way away.
Steve Seisloff again from Florida today. I have another quick one for Preston. What's to become of the old arrays, assuming they're stowed adequately on Columbia? Are they destined for a museum eventually?
Gee, that's a good question. I don't think we have a specific plan in mind at the moment. Those arrays were contributed by the European Space Agency, and of course they're very interested in their state and in looking at them. But I'm not offhand. I don't think we have a specific plan worked out. They will come back to Goddard Space Flight Center first, I believe, and our engineers will look them over and examine them. And I don't know whether we're going to wind up keeping one and giving one to the Europeans, or whether they want them both back, or whether we're going to put both of them in the Smithsonian or what. But I just don't know what the plan is at the moment.
Okay, that's all the questions we have for today's briefing. We'll end with the usual programming notes for those who missed a lot of the beautiful television that came down of the rendezvous, the grapple and the solar array retraction. That'll all be shown in today's Flight Day Highlights package. That will begin running at 1 o'clock Eastern Time and show on the hour, every hour, throughout the crew's sleep period. So that's at 1 Eastern, noon Central Time. The EVA, the first spacewalk, as Brian mentioned, begins about 1:30 in the morning. Eastern Time. Again, they can get out the door as much as an hour earlier, so stay tuned to NASA TV for that.
And we're with you guys on the middeck, enjoying your pre-EVA snack there.
From the middeck of the Shuttle Columbia, John Grunsfeld facing you, and Rick Linehan with his back to you, the two spacewalkers for tonight. They're being assisted by Mike Massimino.
The guys downstairs have done a great job cleaning up the middeck, keeping things straightened up. You know, we do have 4 suits here aboard Columbia, internal airlock, not a lot of room, and they're maximizing every amount of space that we can, so they're doing a great job.
We concur wholeheartedly.
Mike Massimino helping Rick Linehan complete his suit-up procedures. Again, Linehan will be wearing the spacesuit with that is pure white with no red stripe designations. John Grunsfeld, who is designated as EV-1, the prime spacewalk repairman and servicing man for this mission, will be wearing the spacesuit bearing the solid red stripes.
Der US-Raumfähre Columbia beginnt am Morgen ihre Wartungsarbeiten am Weltraumteleskop Hubble. Wie hier im Trick wollen die Astronauten die alten Solarzellenflügel des Teleskops durch einen neuen, leistungsfähigeren ersetzen. Insgesamt sind 5 Außeneinsätze geplant. Danach soll Hubble 10-mal so leistungsstark sein wie bisher.
I'm low price. You guys ought to be hot. Check your comm with IMCC as a courtesy, please.
Houston, Columbia, EV1. How do you read?
Loud and clear, John.
You're loud and clear as well, Mario. Houston, Columbia, EV2. How do you hear?
Loud and clear, Rick, as well.
That's you too, Mario.
Okay, both ECMs power to battery.
more. Michael Holmes is with us at the CNN Center. Michael, I understand not only are they working, but so are you with Guest.
That's exactly right, Richard. The man with the best job in the world, if you ask me. Miles O'Brien has been keeping an eye on all the goings-on in orbit. He joins us now on set here to talk about what's been happening. You know, I'm a convert. I love all this stuff. Tell us what's been going on.
Well, this is the first of 5 planned spacewalks, Michael, and the Space Shuttle Columbia thus far has had a fairly problem-free mission, with the exception of a problem with the cooling system, which NASA has determined is okay and sufficient to continue with the mission. And that's why you're seeing this scene right here. Live pictures right now from the Space Shuttle Columbia. This picture shot from the robotic arm, 15 meters long, shooting down to the airlock of the Space Shuttle Columbia. And that's spacewalker John Grunsfeld, who is the only return visitor to the Hubble Space Telescope on this particular mission. He and his spacewalking partner, Rick Linehan, are slated to spend about 6.5 hours in the void, beginning the process of upgrading the Hubble Space Telescope, now 12 years in orbit. Specifically on their plan of action today, and after they get through with about an hour of initial setup, getting their tools straight, putting some protective covers on the $6 billion telescope, they will be swapping out one of the huge solar arrays, the starboard or right-hand side solar array of the Hubble Space Telescope, with a newer version which is about a third again smaller and yet 20% more efficient. The smallness is a good thing because that reduces the drag on the telescope, which reduces its altitude loss over time. And of course the efficiency is something that engineers are quite pleased about. As you can see right here, you can see the tethers. There's a dual tether protocol. That's what NASA calls it. In essence, it's kind of like a rock climber, lead rock climber. You always have 2 attach points to either the Space Telescope or the Space Shuttle Columbia. Just a matter of safety because you certainly don't want to float off into the void. One of the things that's kind of interesting about this Hubble repair mission is the first time that there'll be helmet-mounted cameras on the backside of Grunsfeld's helmet. You can't really see it too well, but there's a camera there with wide, medium, and a close-up camera. And they'll be able to feed down images, close-up, of the work they're doing on the Hubble Space Telescope as they're doing it. I told them before they left, I said, whatever you do, take a few moments and look out over onto the horizon. Give us some nice wide shots of the Earth as it passes beneath with the Hubble Space Telescope in the foreground. They promised me they would do that.
And of course they listened to you, Miles. Now listen, you've won me over, as I said, but there's always going to be people who say, you know, a $6 billion telescope, the wings they're putting on today, I think, are $19 million. Is it worth it?
Well, yeah, this is, you know, we're talking about answering very fundamental questions here. The Hubble Space Telescope, which has had a tremendous roller coaster ride. You'll recall in 1990 after it was launched, it was horribly myopic. It was a laughing stock the world over. They went up in 1993, the first servicing mission. They were able to put essentially $1 million eyeglasses, multi-million-dollar eyeglasses on it. Ever since, it's been rewriting the astronomy books. And we've discovered for the first time definitively that there are black holes in the universe, but not only are there black holes, they're ubiquitous. We've seen the galaxy formations very early on, very close to the time of the Big Bang. If those questions are not important to you, there's nothing I could say to you right now that would tell you it's worth $6 billion. Finding out the answer to questions like that is something that a lot of people find worthwhile.
They're not the sort of things that you're going to get a result from right now. This is not an instant gratification project, but incredible the pictures that have come back out of it, and also the sort of things they're doing now. And as we've said before, you take this stuff for granted.
Yes, here we are. We're looking at something that's about 550 kilometers above us, moving along at 28,000 kilometers per hour. By the way, what he's got there is that's a tool rack. That's a glorified tool belt, a spacewalker's tool belt, which has all the important equipment that they need, including this, the pistol grip tool, which allows them to do the work they need to do during the course of this spacewalk. We'll be watching it all night, so stay with us.
I need one of those in my workshop. Miles, thanks very much. Right, it's terrific to see you. Thank you very much for bringing us up to date. As I said, the man with the best job in the world, in my view. That's a look at the current mission of the Space Shuttle Columbia. Juanita and Richard, back to you in London.
Okay, there you go. Oh, wow. Beautiful view.
And John Grunsfeld now in the open cargo bay of Columbia. As he emerged, he would have had a view of the Sahara Desert at an altitude of 362 statute miles.
To the left, EMU D-ring, unlocked. John. Hey, Jim, my right waist tether. Stand by, John. Go ahead, Rick. Jim, John, go back inside for a minute, would you please? Go back. Just a minute. Yep, Jim, my right waist tether is on a handrail standoff. Okay, copy, right. The gate is closed. Okay, I see that, and go ahead and work with Rick inside, please. Thank you. Okay, Rick, your safety tether hook card is swung back in. Thank you. You can hand that to me. There it is. Thank you. Okay, John, you have that. And I'm going to release the tether on the bottom of the tool handle. I have the tool board. Okay, I'm coming down. Okay, you have it, John. Okay, I'm bringing it out. Hello, Mr. Hubble, the telescope. We're here to give you more power, see the planets, stars, and the universe. Okay, thanks for those words, John, and report complete on the safety tether hook guard. Wilco? Okay, Rick, your go for your translation adaptation. Okay, Jim, I'll close the thermal cover. I'm going to take a quick inspection inside. Everything looks good. Don't see anything loose. I'm closing the covers. Copy, thank you. Given the safety tether hook guard is installed, the gate is locked. Copy that. You go for the mini TA. Okay. Rick, now you too can say you work in a vacuum. It's amazing to be here. Welcome outside, Rick. Oh, wow. Okay, for your translation adaptation, why don't you come on up for a moment? Okay, here we go. Okay, it's coming. See good motion? It nearly free spins. Jim, I'm taking the... Yeah, I can... Yeah, I can ratchet it off. Okay, take your time, throw the ratchet, and then you can have two hands on it.
Grunsfeld now will use the pistol grip tool to make 20 turns on a clamp that will disengage this solar array drive assembly clamp from the starboard wing of the telescope, which soon will be removed and transported down to the rigid array carrier to be stowed for the trip back home.
5. Indicators moving. 6. 7. 8. 9. Close, Rick. 10. 11. I feel loosening. 12. 13. I'm backing off. Rick, you have the array. I have the array and I'm tilting it. That's good. You're okay. Good. Good to maneuver, Nat. Okay, coming slowly back away.
The starboard solar array on the Hubble Space Telescope is now free of the observatory in the hands of Rick Linehan, mounted at the end of the shuttle's robot arm.
I can see one of the, on this array at the base, one of the pins protruding about 2 feet, maybe a little less. It looks like about a foot past the splitter bar. Yeah. Okay, roger that. No safety issues. Concur. Nope. Possibility, tell you. They really do come out. 10 blend back in. Okay, we heard 13 turns. Yep. $14, $15, $16, $17, $18, $19, $20. Okay, the indicator is in the open range. Jim, the MOI tape is in good condition. The SATA clamping ring is in good condition. All the ground strap rings look fine. I think the clamp is good. Okay, copy. Fleet and the MOI for soft touch interference. And all the MOI tape is good. Okay, you're on your way to the rack. On my way. Okay, I'm going to hand over to Mike for a bit here. Copy.
Jim Newman handing choreographer chores over to Mike Massimino at the aft flight deck of Columbia, while Rick Linehan holding the starboard solar array wing of the Hubble Space Telescope, about to be maneuvered down to the rigid array carrier to stow it for the trip back home. John Grunsfeld also will be making his way down to that area to assist in the stowage of that array. After the old array is stowed in the rigid array carrier, Grunsfeld will make his way back up to the telescope and begin the process of removing the old diode box assembly, while Rick Linehan works to retrieve the brand new diode box assembly that will be hooked up to the brand new rigid array to be installed shortly on the starboard side of the telescope.
Delay that 30 minutes, please.
We copy, thanks.
You're looking at the perspective of Rick Linehan as he holds on to the starboard solar array wing, being transported by Nancy Curry down to the rigid array carrier, where he and John Grunsfeld will stow this old array for the trip back home.
Okay, have the forward off. I'm continuing down. Thank you, Nancy. John and Rick, as you guide the solar array into the SATA clamp, you'll then rotate it into the latches. Copy that. Copy.
Linehan receiving guidance from Mike Massimino at the aft flight deck of Columbia, who is basically directing Linehan in the fine-tuning of his orientation so that he can lower the solar array down onto its clamps on the starboard side of the rigid array carrier.
Okay, I'm going to keep going one more foot. Okay, thank you. Maybe a bit aft, John. Keep coming down. Okay.
Once the array is in its clamp, Grunsfeld will use the power grip tool, the pistol grip tool, that high-tech screwdriver. He'll make 22 turns of the screws to firmly lock the array in place.
Move the forward end slightly to starboard. arms. Another inch. Okay, John. Okay, Rick. Okay, the arm is stopped. Thank you, Nancy. Okay, push it down at this end, Rick. Hey, can you hold it right like that? I can. Okay, push the starboard end down, side down a little bit. Stop there. Okay, drive in.
Okay, Rick, you might want to roll the array a little bit to your right, just a couple inches, just a couple degrees.
Okay,
I think you might want to pull the array starboard just a little bit. Good, good, good.
Perfect. Thanks, 3. Yeah, it was kind of the floor constraint. Yeah, I thought it was. I couldn't see. Thanks, Dad. 5. 6. 7. Closing. 8.
Look at the 22 turns MTL flip.
9. Thank you. Deconstriction. 10. 11. 12. 13. 14. 15. 16. 17. 18. 19. 20. 21. 22. MTL slip about 22 and a quarter.
Copy, MTL slip at 22 and a quarter. Check the indicator closed.
Okay, stand by, I'm still in my PG. Mike, the indicator shows closed.
Copy, John.
And the spindle lock is on.
Copy, spindle lock engaged.
When you get to the end there, just look up for just a second. Okay, we'll go. John, I see tiny bits of silver flecks on the bicep bellows, like we must be residuals from what we saw yesterday during the compression. Yeah, I'm seeing a little bit of a snowstorm myself.
Okay, John, you want to inspect the forward latch alignment?
Thank you. Thank you, Mike. Looks like it's right in there, Mike. Copy. Straight up and down.
A good view of John Grunsfeld on the left and Rick Linehan at the end of the shuttle's robot arm on the right, ensuring that the starboard solar array on the from the Hubble Space Telescope is firmly in place, and the rigid array carrier for the trip back home now firmly latched and clamped in place. They just wanted to make sure that the alignment of that array in its bracket was proper, and it seems to be. So with that, Grunsfeld and Linehan can now press ahead to begin the process of changing out the diode box assembly associated with this piece of hardware. The old diode box that connected to the starboard solar array will be removed from the telescope and replaced with a new one compatible with the brand new rigid array that will be installed in the telescope later this morning. This is John Grunsfeld making his way up the Hubble Space Telescope to the area where the diode box assembly is located on the starboard side of the telescope. This again, the electronics box that routes power from the solar arrays to the 6 nickel-cadmium batteries in the telescope. The old starboard diode box assembly will be removed and replaced by a brand new unit which is compatible with the brand new rigid array.
We're going to hand over.
And what we're seeing here is, John, do it again for him. Looks like we have KU. Okay. The flap is not engaging over the Tang interface. And John, we'll take your assessment of what the options might be. Sorry, with you, I'll hop out and take a look down there. 2, 3, it's all yours. Thank you. You have it, Rick. Looks good.
Rick Linehan now in control of the brand new rigid array, 640-pound solar wing that will be installed on the starboard side of the Hubble Space Telescope and will fold open like a book, exposing its gallium arsenide solar cells for additional power for all of Hubble's instruments.
I see you roll.
The EVA officer here in Mission Control, Dana Weigel, reports to Flight Director Brian Austin that the spacewalkers are running about 30 minutes ahead of the timeline.
That looks great. Okay, I'm going to dip it down to you, John, a bit. I'll just bring it back up again. That's going to be the hardest one for me, I think.
Columbia Houston, when you get to it, your go for PFR ingress and SA3 connector mate.
Copy, thank you.
Vance, I feel like I've got a little bit of forward pitch in the plate.
Yeah, and she's maneuvering you to flat. She'll give you a call when you're flat. Okay, so the solar array is a bit ahead of you now.
Yeah, I'm going to hold here until I'm flat.
Good.
Rick Linehan then will be moved back down to the rigid array carrier to perform closeout work on the old solar array, which was berthed in the rigid array carrier earlier this morning, before being transported back to the telescope to work with John Grunsfeld to fold open the new rigid array, to engage locking bolts on that panel, and then to release the brake on that panel, which will enable it ultimately to be driven and slewed back and forth.
Thermal coverage closed. Roger, thermal cover closed.
Guy on here. One right here. And Jim, I'm right off the right shoulder. Great.
Jim Newman continuing to use his pistol grip tool, a high-tech screwdriver, basically weighs about 32 pounds here on the Earth, to disconnect bolts holding the old diode box assembly along the
2 Astronauten der US-Raumfähre Columbia haben damit begonnen, die Sonnensegel des Weltraumteleskops auszuwechseln. Die neuen Solarzellen sollen die Leistungskraft von Hubble um 20% steigern. Außerdem können künftig alle Instrumente des Teleskops gleichzeitig eingesetzt werden. Hubble umkreist seit 12 Jahren die Erde.
Dann nämlich sollen sie Hubble eine neue Energiezentrale einsetzen.
Der Patient ist den Astronauten gut bekannt. John Grunsfeld gehörte schon zu der letzten Crew, die dem berühmten Weltraumteleskop vor gut 2 Jahren wichtige Neuteile eingepflanzt hatte. Und er freue sich wirklich, sagte Grunsfeld beim Ausstieg in rund 600 Kilometern Höhe, seinen alten Freund jetzt wiederzusehen. Es waren vor allem die vielen Reparaturmissionen, die Hubble berühmt gemacht haben. Wegen eines Schleiffehlers in der Optik war das Gerät von Anfang an halb blind und damit für viele Kritiker ein Flop. NASA-Techniker verhalfen ihm mit der Zeit doch noch zur gewünschten Sehschärfe. Bei diesem vorerst letzten Besuch soll Hubble für die nächsten 8 Jahre fit gemacht werden. Dafür bekommt das Teleskop unter anderem neue Solarsegel, kleiner und leistungsfähiger als die bisherigen. Mit der größeren Energieausbeute können in Zukunft alle 4 Hauptkameras an Bord gleichzeitig betrieben werden. Und der erste Ausflug verlief erfolgreich. Unter größter Konzentration gelang es den Astronauten Grunsfeld und Linehan innerhalb von 7 Stunden, das erste Solarsegel auszutauschen. Nach anfänglichen Pannen sind die NASA-Techniker jetzt optimistisch, in den nächsten Tagen das zweite Segel und das vielleicht wichtigste Bauteil, das Steuerungsmodul, wechseln zu können. Mit der neuen Technik soll das Teleskop noch bis zum Jahr 2010 im Weltall forschen, bevor Hubble durch günstigere, kleinere Satelliten ersetzt wird.
I know about the Hubble telescope and the Space Shuttle Columbia can be written on a very small piece of paper. Someone who does know is our space correspondent, Miles O'Brien, joining us again live. Miles.
Michael Holmes, good to see you. Let's talk a little bit about what's going on in and around the Space Shuttle Columbia and the Hubble Space Telescope, which are pretty much in this configuration as you see right here in this model. The Hubble is in a glorified Lazy Susan in the aft section of the payload bay. It was tilted around this way so that the starboard solar array would face the astronauts as they conduct their efforts this evening. One of them, Rich Linehan, will be mostly on this robotic arm. The other one, John Grunsfeld, will be free-floating, replacing one of those solar arrays, hopefully not causing the Hubble to tip over like I just did. Let's take a look at some of the pictures which fed down from the middeck of the Space Shuttle Columbia a few hours ago as the spacewalkers were getting ready. This one right here, that's Jim Newman. He's going to be inside during the course of this spacewalk today, helping out, making sure the team stays on their timeline. He'll be headed out Tuesday overnight hours, Eastern Time, U.S., to do his first spacewalk with his partner. But as you can see, they're putting on the $14 million trousers, if you will. Those are the world's most expensive suit. This is really, the best way to think about it is the world's smallest spacecraft. They say it's a lot easier to get it on in weightlessness. It doesn't look so easy there right now as John Grunsfeld gets some help from Mike Massimino, another crew member who will be out spacewalking in another 24 hours or so. The suit up went without a hitch. They got out on time. And we got a few pictures down before we lost satellite link. Let's take a look at those pictures as the pair of spacewalkers stepped into the void, if you will, and floated around. This is John Grunsfeld up here. He's the one who will be free-floating, doing the work sort of tethered to with various tethered lines. And that's Rich Linehan down there. He's going to be spending most of his time as sort of a human socket on a socket wrench, anchored down to the end of that 15-meter robotic arm, doing a lot of work as he's being transported by the robotic arm operator, Nancy Curry, who'll be using these windows to keep track of where the spacewalkers are. Before they left, I asked Rich Linehan about some of the subtleties, the nuances, if you will, of spacewalking.
The other thing that amazed me is sometimes it's just busy work. It's nothing, you know, scientific instrument. It's great to put one of those in, but most of the work involves going back, getting tools, figuring out how to use the tool, moving around, translating, getting something on that fits just right, making sure you don't damage something while you're putting it on. And it's so much technique and movement and being very careful and very definite about how you move and what you do.
So much busy work. Got to say, they spend an awful lot of time preparing, training. You might say they're the most well-trained, highly paid optical technicians in the world, or perhaps, more accurately, out of this world.
You know, the thing, give us a sense. I mean, it's great when you get the model up here because it gives us a sense of. Now, where were they? Were they down this end? Were they?
The shots that we saw just now were right here. This is the airlock area right here. And they were shot by a camera right in the elbow of this 15-meter arm. It was pointing down at them as they were beginning the process of transitioning toward the Hubble Space Telescope. It's kind of difficult to see where they were. They were getting their tools set up.
And what about the dimensions here? Where, I mean, how big is the cargo bay?
This is about 60 feet long. It's about the length of a school bus. The Hubble Space Telescope itself is 4 stories high. It was designed and, as a matter of fact, was brought to orbit on a space shuttle, the Space Shuttle Discovery, back in 1990. So if you were to lay it on its end, it would fit very neatly into that payload bay.
It's amazing stuff. All right, up there spinning around. How fast are they going?
28,000 kilometers per hour.
28,000 kilometers an hour. There you go. Moving around right now. That's all from us. Back to Anita in London. We'll be keeping track, or Miles will be keeping track on this. Fascinating stuff.
Boys with toys, that's what it looks like to me. Thanks, Michael.
More than 5 feet from me. Coming up to about 4 feet. Okay, I don't think it'll get any closer than about 3, so it's good clearance. How's it looking for me, John? Looking really good. Okay.
Once Linehan inserts the array mast into the hole that you see next to John Grunsfeld, who's wearing the suit bearing the solid red stripe, standing on that portable foot restraint on the side of the telescope, the solar array will be captured by 3 tangs, which will essentially soft dock the array. Then Grunsfeld will engage a clamp on the solar array drive assembly that will lock the array in place and set the stage for the mating of a number of electrical interfaces between the solar array drive electronics and the array itself.
So we're about 1 foot from the lip of the telescope. Okay, when we get to be closer in, John, I'm going to save up some arms. Okay. We still have a ways to go. Okay. It's just even with my chest right now.
John Grunsfeld helping to guide Rick Linehan the final few inches for the installation of the starboard rigid solar array, the brand new array for the Hubble Space Telescope.
About 8 inches.
3 hours, 45 minutes into this morning's spacewalk as Columbia sails over southern Africa.
About 6 inches. I'd like to recommend we pause for a moment. Okay. Okay. Please do a quick check. Rick, you have everything stored up in your arms you need? Not enough yet, Jim. So, Nance, you drive in 6 inches slowly, and I'm going to store it up instead of allowing the array to come in. Okay, and I'll hold it at this side. Okay. Okay. And I'll give you a call when I think I'm good. Okay. All 3. Okay, let go. I'm off the array, guys. Stay close.
Soft docking of the starboard rigid solar array now confirmed.
Just pause for a moment and regroup. Yep, concur. That's firm, Jim.
So Rick Linehan has now released his grip at the end of the rigid array, and John Grunsfeld is now engaging the solar array drive assembly clamp.
A giant space telescope is getting an ambitious repair job. 2 astronauts from the Shuttle Columbia are spacewalking and spaceworking on the Hubble telescope. They're replacing a solar panel and over the next few days will install a new power unit and a powerful camera. NASA says the spacewalks are the most challenging yet.
The brand new solar array is now being unfolded by Rick Linehan.
Pat, slowly bring me to port, please, about a foot. Roger that, that's coming. Thank you. The rays look beautiful. Okay, that's really nice, thanks. I'll stop. And Jim, with your go, I'm going to come in very slowly now. Your go. Okay, here we go, John. Okay.
This array, once unfolded, will be 25 feet long and 8 feet wide.
Okay, the ramp is just touching the bolts. Slow down. Slow down. Nice rate. Good rate. That's the only rate I can get going. Actually, if I stop, I can't get it going again. It's going up over the bolts. Okay, that's great. Okay, the bolts clicked in. Okay, I see it open. And I can look right down the spine of it and see the junction and also that the bolts are in over their stop. Good job.
And Rick Linehan has now completed work on the deployment of the brand new rigid solar array on the starboard side of the Hubble Space Telescope. With that work having been completed, John Grunsfeld and Rick Linehan will soon swap places, with Grunsfeld taking a turn at the end of the robot arm and Linehan tethering himself as the so-called free-flying spacewalker. The next task for Linehan will be the installation of a thermal cover over Bay 10 of the Hubble Space Telescope. This in preparation for the change-out of the critical power control unit on the Hubble Space Telescope on Wednesday that these two spacewalkers will be engaged in. And houses the scientific instrument command and data handling computer, the data interface unit that distributes all of the data relays between the scientific instruments and Hubble's primary computer, and 3 electronic control units. The cover on Bay 10 will maintain the proper thermal conditioning for those sensitive instruments during the time that the Hubble Space Telescope is completely powered down for the power control unit change-out on Wednesday. One final cable will be mated at the newly installed starboard solar array, the new rigid array installed on the starboard side of the telescope. John Grunsfeld will mate a cable called the P601 cable that will correctly route power from the new array to the diode box controller in the telescope. That electronic relay box essentially routes power correctly from the array to the 6 batteries in the telescope, the 6 nickel-cadmium batteries that power all of Hubble's systems and instruments. This is Mission Control Houston. Now 5.5 hours into this morning's spacewalk by John Grunsfeld and Rick Linehan as they continue to work to swap places at the end of the shuttle's robot arm for the final tasks of the morning.
That's mated. P601 is mated. Copy, P601 mated. Your next is the MOI tent. Okay, I'm going to start the cap now. Houston, Columbia for EVA.
Go ahead, Mike.
P601 mated.
Copy that, and we see it.
How's that going, Rick? Done. Okay. Ready for me to come aboard? Not yet. Okay. I see good motion. It's moving. It's lined up, Jim. I got an MTL slip at 23. Reload pointers are aligned. Okay, you go to the aft latch now. Let's hope the aft doesn't act like the forward. It doesn't. Okay, ready for motion, Dad.
That is good news. The extra torque setting on that ratchet did the trick in securing that fourth and final latch on the starboard bracket in the rigid array carrier, in which the old starboard solar array was berthed earlier today following its removal from the Hubble Space Telescope. Linehan now will re-engage the aft latch on that starboard bracket in which the old array is mounted.
Verify EV1 and EV2 O2 valves open.
This is Mission Control Houston. You're looking at the new solar array, the starboard solar array on the Hubble Space Telescope.
Okay, and John, right before we cut off here, would you give us your O2 off your DCM? Yep, I was just going for that. 563 and increasing. I think it was about 490. Oh, we missed it, sorry. Okay. 490 at ingress.
Grunsfeld and Linehan, who installed this new solar array, now on Columbia's airlock, finishing up their first spacewalk of this mission.
This is Mission Control Houston. You're looking at a replay of video that was taken during the first spacewalk of this mission that ended just about a half hour ago. You can see astronaut Nancy Curry in the hat operating the robotic arm. She used the robotic arm to maneuver Grunsfeld and Linehan throughout the payload bay as they were doing their tasks of removing and replacing the starboard solar array of the Hubble Space Telescope. Astronaut Mike Massimino, who will be doing a spacewalk tomorrow, was working inside Columbia, helping out Grunsfeld and Linehan as they went through their spacewalk. This is Massimino's first spaceflight, and tomorrow will be his first spacewalk.
Astronauten John Grunsfeld und Richard Linehan ihren außergewöhnlichen Spaziergang. In Wirklichkeit harte Arbeit, 7 Stunden lang ohne Pause. Fest verbunden mit der Columbia tauschten die beiden Amerikaner das erste der beiden Sonnensegel aus. Die neuen, 19 Millionen $ teuren Segel sind deutlich robuster als ihre Vorgänger. Ihre Solarzellen sollen Hubble 20% mehr Energie liefern. Insgesamt sind während der Mission 5 Außeneinsätze geplant. Bei einem davon soll Hubbles Steuermodul ausgetauscht werden. Dafür wird das Teleskop erstmals seit seiner Aussetzung im All vor 12 Jahren vollständig abgeschaltet. Wenn alles glatt läuft, muss das 11,5 Tonnen schwere Riesenteleskop erst in 2 Jahren wieder durch den TÜV. 2010 soll Hubble dann zur Erde zurückgeholt und ins Museum gebracht werden.
Columbia haben ihren ersten von insgesamt 5 Weltraumspaziergängen erfolgreich beendet. Am Weltraumteleskop Hubble ersetzten sie in einem 7-stündigen Einsatz das erste von 2 Sonnensegeln. Morgen sollen die Reparaturarbeiten weitergehen. Ziel ist es, durch die neuen Segel mehr Energie zu gewinnen, damit alle Hauptkameras und Sensoren an Bord zum ersten Mal gleichzeitig bedient werden können.
Astronauts have successfully performed the first in a series of high-tech tune-ups aimed at improving the eyesight of the Hubble Space Telescope. Veteran spacewalker John Grunsfeld and first-timer Richard Linehan from Space Shuttle Columbia hung the first of 2 solar wings on the Hubble. NASA scientists say the new smaller wings will boost the telescope's power by up to 30%. And finally, a dose of reality and a bit of odd democracy took place in the skies over Italy on Sunday. The pilot of a charter flight to Cuba had passengers vote on whether to continue the transatlantic journey after flames were seen streaming from one of the SR jet's engines during takeoff. The pilot got the plane in the air and announced his intention to continue on to Cuba after resolving the problem. His reassurances, though, did nothing to calm the jittery nerves of the 250 passengers aboard the flight, so he called for a vote. And they voted, and it has to be said, voted overwhelmingly to return to Milan's Malpensa airport. Perhaps not surprisingly either. I'm Fionnuala Sweeney in London. That is World News Europe. World Business Today is up next. But first, another quick look at the views from space during Monday's spacewalk.
Okay, that's really nice. Thanks. I'll stop. And Jim, with your go, I'm going to come in very slowly now. Your go. Okay, here we go, John. Okay.
This array, once unfolded, will be 25 feet long and 8 feet wide.
Die Besatzung der US-Raumfähre Columbia hat mit der Modernisierung des Weltraumteleskops Hubble begonnen. In etwa 560 Kilometer Höhe über Afrika ersetzten 2 Astronauten ein Sonnensegel. Der zweite Solarzellenflügel, die Energieschaltzentrale und die Kameras werden in den kommenden Tagen ausgetauscht. Die von Hubble aus dem All gelieferten Bilder gelten als wissenschaftliche Meilensteine.
Well, good morning, everybody, and welcome to today's mission status briefing following the completion of the first of 5 planned spacewalks for this Hubble servicing mission of Columbia. I'll introduce the panel as the case from yesterday, and each person will have some opening comments, and then we'll throw it open for questions. To my right is Brian Austin, once again the lead flight director for STS-109. To his right is Preston Birch. He's the Hubble Space Telescope Program Manager from the Goddard Space Flight Center in Greenbelt, Maryland. To his right is Ann Kenny, Director of Astronomy and Physics from NASA headquarters in Washington. And to her right is Dana Weigel. She is the lead EVA, Extravehicular Activity, or Spacewalk Officer for this mission. So with that, I'll turn it over to Brian, let him take it from there.
Thanks, Kyle. We had a great day today. EVA number 1 went pretty much as planned. We got out the door on time. We were anticipating possibly getting out a little early today, but the crew took their time and worked through the schedule and the procedures, and we got out pretty much on schedule. For the books and the records, 7 hours and 1 minute was the duration of the EVA today, but pretty much ran again, as I said, as expected. Spent a little extra time working on getting the solar array latched down on the rigid array carrier, but eventually got that all secured and everything's fine, and the orbiter's doing fine. We're working no issues on the orbiter. We've had some periods of some Radicom that we've had to deal with pretty much throughout the day, and that's just going to be an artifact with us throughout the mission, but it's really caused no real problems or concerns. Tomorrow, flight day 5, will be EVA 2, and spend 1 more day in changing out the plus V2 solar array, and then finishing that day up with replacement of the reaction wheel assembly. Again, a great day, and it's just been marvelous watching the EV crewmen and the telescope and all the pictures coming down. Sometimes get lost in watching the video and listening to all the activity, but it was a really exciting day, and I look forward to 4 more EVAs. Preston?
Okay. Well, I think you stole my lead-in line there, Brian. We did have a great day. We're extremely pleased, very excited about how much we got accomplished today. We accomplished everything that we set out to do. In addition to exchanging the minus V2 solar array wing, we also accomplished our planned power control unit preparation work, and so we're right on schedule with everything that we have planned for the first day, and we're in great shape to begin tomorrow's activities. So that's really all I've got to say. I think Brian's told you what we have on tap for tomorrow, so we're extremely pleased to be in this position.
I just wanted to remind you a little bit about the story of solar arrays. When Hubble originally launched in April of 1990, it had a big problem that everybody knows about. That was the aberrated mirror. But it also had a small problem in that there was jitter every time the telescope crossed the terminator. So every time the telescope went from day to night, it was like the telescope was ringing, and every time it crossed from night to day, it started ringing again. And this turned out to be traceable to the solar arrays, and the frame, the bi-stem as it's called, a frame of the solar arrays was not well thermally isolated so that it would change temperature when it crossed the terminator, it would cause it to ring. Now that solar array was made by the European Space Agency. The European Space Agency went off and redesigned the solar arrays. They did a fabulous new design that stopped the ringing. They did a concertina sort of a layer around the bi-stem so that it was very well insulated thermally. The ringing stopped. And these solar arrays have been in operation since 1993. They've been very successful solar arrays. They were also very successful solar arrays today when we rolled them up because they just rolled up, or I guess that was yesterday we rolled them up. The days are already running together. They rolled right up very neatly and packed away. If you remember when we did the change out in 1993, the solar arrays had to be thrown out because they were crooked. So these new solar arrays done by the British Aerospace Agency were fabulous solar arrays. But we are now replacing them with solar arrays that have more power. The solar arrays that we took off have slowly degraded in power. And so the replacement that we're putting in is about 30%, is going to provide about 30% more power than today's solar arrays. And they are also more rigid, and that makes a sort of an easier ride for the telescope. If you can, the backdrop here actually shows you those solar arrays. These were the ones put in 1993. You can see there's still a little bit of floppiness in those solar arrays. They're still kind of big floppy things, so there still was a little bit of extra drag from the solar arrays. These new solar arrays are rigid and more drag-free. They will just give a cleaner ride to the telescope. The telescope will be able to dwell more quietly and give us, we really hope they'll give us a nice long science lifetime on Hubble Space Telescope.
Thanks, Ann. Dana.
We had a very successful EVA today, as you've heard from the other folks. Both EMUs performed well. EMU 1, which is John Grunsfeld's suit, stopped sending EMU data at the beginning of the EVA. We had him call out different parameters to us so we could track his consumables. And his suit did look nominal from the readouts he was giving us. At the beginning of the EVA, the crew was actually ahead by 30 to 40 minutes. When they went to stow solar array 2, we had some problems with the latches. After trying to realign the solar array a couple of times, we realized it was not an alignment problem. We had the crew increase the torque, and they were able to get the latches driven and properly seated. One of the new tasks, or the interesting task that we did today, is the solar array installation. From an EVA perspective, we haven't done mass handling like this. The solar array weighs 640 pounds. Its center of gravity is offset. And Rick Linehan mass handled the array by himself and rotated it 180 degrees for installation. And he made it look really easy. So we're looking forward to another successful EVA tomorrow.
Thanks, Dana. Okay, we're ready for questions. We'll start with Mark and see if Frank's got some, and then we'll head to Florida. Go ahead.
Thanks. Mark Carreau from the Houston Chronicle. I had a couple of questions. The first one is just what checkout you do on this solar array today to find out whether it's working up to spec, or do you have to wait until you get the second array and check them out in concert? Can you sort of explain what's involved there and when you sort of know something good?
Yeah, I'll take that. We do 2 sets of tests on each wing each day when they're installed. The first is a very brief aliveness test that takes less than 10 minutes to perform. And basically what we're looking for is the output signature from the solar array. We want to make sure that all the electrical connections have been properly mated, that we're getting power to the diode box assembly that was installed, and that's been hooked up properly to the spacecraft bus. And we're also checking telemetry. The functional test is a more thorough test, and that's done after the astronauts return to the cabin and during their sleep period. And there we do a more detailed analysis and checkout of the diode box assembly. And we check there primarily for critical functions that are needed for the long-term mission.
Anything else, Mark?
Thank you very much. And my second question had to do with the sort of length of the spacewalk that you saw today. You're going to do the mirror of that spacewalk tomorrow, plus add the task of the reaction wheel. And I just wondered if you have enough time to do all that, and if something causes one task or another to take longer, how would you deal with that?
The task is actually, the task for tomorrow, you're right, we are installing another solar array. But the overall EVA has a couple of differences. One is we don't have to do the initial payload bay setup. Today we had to do an installation of a foot restraint into the arm, and we had to install a rigidizing post on the telescope. That takes about an hour. And tomorrow's setup is much shorter. In addition, we made it a harness today to power part of the diode box, and that task doesn't have to be done tomorrow. So the days are very comparable in time.
Frank, yes. Greg.
Frank Morning with Aviation Week on the what you're going to do with the extra power you're getting. And I have two. Exactly how much extra power do you expect to get? You said 30%. Is it 20 or 30? 20?
It's 20 relative to what the solar arrays were in 1996. But they've degraded since 1996.
Right, right. The
So
20% number, we tried to make more of an apples-to-apples kind of a comparison.
So if you compare it to the lifetime of the solar arrays, 20% is a good number. If you compare them to the power we got the day before we powered down Space Telescope, it would be more like 30%. Right. And basically, it allows you to keep operating the instruments in parallel, which is what we do now. So you do one instrument that is the main science pointing, and you take serendipitous images in the other instruments, and that allows you to maximize your scientific return. If we didn't have this increase in power, we'd, you know, the old solar arrays would continue to decrease, and we'd eventually be stuck with just operating just one instrument at a time.
Now, there's a couple of other aspects too. The current solar array has lost some of its power due to failures in the electrical wiring. So it isn't just the normal radiation kind of degradation. Also, we'll be installing the NICMOS cryo cooler, NICMOS cooling system, and that consumes a fair bit of power. So that's over and above the suite of instruments that we will have on board. So in the post-servicing mission 4 era, when we will be installing 2 additional science instruments, the power requirements on the observatory are quite high. And so the addition of these more powerful arrays will give us a lot more operational flexibility and will enable us to do a lot more exploration.
How does that play out in the after the next mission with the other instruments? Will you continue to be able to operate them in parallel?
Yes, for the most part. I think there are certain situations where we may not be able to have all of them operating in parallel, but for the most part we can.
Okay, let's go to Florida, the Kennedy Space Center for questions, please.
This is Steve Seislaw from Florida today. I'm going to follow up on Mark's earlier question. If in the EVA tomorrow you're running a little behind and say you get to 6 hours, 15 minutes or the 6.5 hour mark, but you haven't started the reaction wheel, are you comfortable going 7 hours or 7.5 to get that done?
Well, we've got the suit capabilities to go longer than that, and generally we're generally going to be constrained in managing our overall time in the crew's day to not keep them out too long that might otherwise jeopardize our opportunities to give them a fair amount of rest and be ready to go out the next day. And that next day would be EVA 3, which is scheduled to be a 7-hour EVA, and we think one of our most challenging from a crew standpoint and crew fatigue. So it's really a balance in playing against how long we want to stay out or can stay out on EVA 2 in order to get one of our top priority items completed at the back end of that EVA, which is the reaction wheel. So I think we'll use our good judgments and the suit consumables we have, but it's a fair chance that if we need to run a little long to complete that full set of objectives and get the reaction wheel completed, I think it's probably the better thing that we get that done. But again, it's a balance of running too long and then jeopardizing the next day. But again, as Dana mentioned today, the overall solar array task in and of itself went well. In fact, we were running ahead of time. In fact, spent probably 40 or 50 minutes working on just taking our time with some contingency and getting it latched down. If you subtract that back out and then apply that tomorrow, I think we're in really good shape in tomorrow's EVA and a good chance that things could go pretty much on schedule and then maybe give us back some of that time to accommodate any problems that come up. So I think tomorrow will play out pretty well.
Okay, thank you. And on the EMU today that you had some trouble getting the information from, are there any plans to take that out of the rotation, or are you just going to compensate by having to give off the readings every hour or so?
At this point, we haven't decided to take it out of the EMU plan. Tonight, we're going to do some more troubleshooting to see if powering it down and powering back up resets some of the circuitry and allows us to get data. It's not required for the ground to monitor the suit data. The crew can see their own data. They have the same basic set of data that we have. They also have a caution warning system that enunciates any messages if they have something out of limits. So it's not a requirement, but we will continue to evaluate that tonight.
This is Marcia Dunn of the Associated Press. First for Preston, now that you've been able to see most of the telescope, how does it look? Any surprises?
No big surprises. One area that was kind of dramatic in a close-up photo was one of the thermal patches that we put on during servicing mission 2. You'll recall that was when we discovered the major degradation in the external insulation. Those patches were constructed, as you'll recall, on the fly using the bi-stem repair kits that we had on hand. And that material was not really optimum for a long duration exposure to the space environment. Those blankets have not fared too well. There's very dramatic splitting and curling in those areas, but those are located on bays that we have hopes of installing the new outer blanket layer material on this mission. So we hope to repair them. If we don't get around to it, there's been no signs of thermal performance degradation, so we're not concerned from an overall performance point of view, at least in the near term between now and servicing mission 4.
Thank you. And 2 questions for Dana. First, I heard Rick Linehan noting how clumsy it was to use the slide wire. What's the problem there? He was talking about a friction problem.
The slide wire, it runs along the length of the payload bay, and there's a slider, which is basically like a collar or a bushing that's supposed to run up and down the slide wire, and their safety tether attaches to that. And we've seen this in the past. Sometimes there's a tolerance stack up, and it's difficult to get the slider to move up and down. So what the crew has to do is sort of manually nudge it along to get it to move along with them.
Thank you. And a second question, I couldn't help but hear Rick Linehan trying to whistle up there. And I'm wondering, is that because of the lower pressure of the oxygen in the suit, the fact that it's pure oxygen, or some other reason?
It is. It's not because of the oxygen. It is because of the lower pressure. It makes it much more difficult to whistle, and he actually did a pretty good job.
Todd Halverson of Space.com, first for Preston Birch. Could you refresh my memory on why I see solar cells on only one side of the new arrays?
Yes, that's because we only keep the sun on one side of Hubble. We don't allow the sun to go 360 degrees around the observatory, and what we do is we pivot the array each time we maneuver it to we pivot the observatory. So we try to optimize the location of the sun on the solar array. And does that answer your question?
Yeah, and just to quickly follow that, is that like some sort of backing I see on the other side of the solar array that might be there for structural integrity or rigidity or something?
Well, there's a frame that's made out of an aluminum lithium alloy, so it's kind of a Z kind of a pattern. It's a cross frame. It's a box section, but it looks like a truss type frame. And then the solar array panels, which were purchased off the Iridium production line, those are a honeycomb panel that's about maybe, I don't know, an inch or maybe a little more thick, with graphite epoxy face sheets on each side. And then the solar arrays, the solar cells are mounted on one side, and on the other side it's sort of a cream color, and that's where the wires run.
Thanks, that helps a lot. For Dana, I was wondering if you could go into a little more detail about what exactly you could not see in terms of John Grunsfeld's suit system as a result of that sensor glitch.
The suit sends down about maybe 20 to 25 different parameters, so we couldn't monitor any of the parameters. It also sends down a biomed signal, which the flight surgeon on console monitors. The suit was sending down a biomed signal, so that data was getting through. It was just the 20 or 25 parameters that we watched. An example of some of those is the oxygen pressure, the CO2 level in the suit, the battery volts. Those are the types of parameters that were not coming down to the ground.
Thanks, and I was curious as to whether the crew inside the shuttle had any way of monitoring that suit data, or if that is something that really only John Grunsfeld could see.
Only John could see that. The data wasn't actually making it out of the suit, so he's the only one that can monitor those parameters.
And just one last one for me, Dana. It seemed that persisted throughout the EVA, that never got better. Is that correct?
That is correct. We think that there's a relay that normally switches back and forth in between the biomed data and the suit data, and we think that relay was just stuck sending biomed data the whole time. So tonight we hope to do a power cycle to hopefully reset that circuitry so that it'll start flipping back and forth like it's supposed to.
Bill Horowitz, CBS. I think this one's for Ann Kennedy, maybe Preston, I'm not sure which. With the two new arrays, and when you can do simultaneous observations with multiple instruments, I know there's not a number for this, but is there a way to maybe just give us a sense of the increased productivity of the instrument when you do that, or is that really not the issue here, and the extra power just drives the instruments?
Well, that's a hard question because it's certainly an increase in science images, and what that helps you with is serendipitous observations. So, for example, if you had a very deep spectrum you were taking with STS, and you could simultaneously take a deep image with ACS, you know, maybe you could discover a supernova. I mean, so it's very hard to quantify what you're going to get out of it. It increases your ability to do serendipitous discoveries. I don't know, Preston, do you want to take a hack at it? It's a hard question. Yeah. It's hard to quantify the increase in actual science.
Well, the other thing to remember is that we have been doing that all along with Hubble. Even with our current arrays and our current suite of instruments, we are able to take what we call parallel observations. For instance, when we're making an observation using the STIS, the Space Telescope Imaging Spectrograph, we'll also take survey images using the Wide Field Planetary Camera 2. And this increases our productivity by something on the order of 50% over what we would normally have on average. It tends to vary depending on our ability to do parallel science. If our main science on a given observation is with WIFPIC 2, it may not make sense to use the STIS in a parallel mode. So it doesn't always equate to that, but on average, it's probably something on that order.
Thanks. I understand. I guess you confused me a little bit. I've seen some press material that was saying that you had never been able to do full-up simultaneous observations. Is that right, or am I just misreading that somewhere?
That's not correct. You know, we have been doing parallel observations for quite some time on HST.
Okay, thanks. And maybe this is for Dana, I'm not sure. They mentioned several times just in the beginning of flaking insulation perhaps, or maybe even paint, I couldn't tell which, and talking about little clouds of debris. I realize it's not significant in terms of volume or something, but is that any contamination issue at all?
Most of the contamination issues that we'll be looking at for this mission are on EVAs 4 and 5. when we open the astral door. So for these first 3 EVAs, we are not overly concerned with contaminants being around the bay. However, we will be tracking the sources and making sure that whatever is causing the debris won't be touched on EVAs 4 and 5.
Thanks. And a simple one for me, maybe for Preston. Somebody addressed this at one of the pre-flight briefings. I can't remember if you did or if it was someone else. As someone who watches Hubble fly over down here all the time and truly enjoys that, I'm just wondering if these smaller arrays and their reflectivity will change the brightness of Hubble as it comes overhead, or if anybody's given that any thought.
Yeah, you were the one that asked that during the pre-flight briefing. Since then, somebody has told me that the source of the reflection was not the arrays on Iridium. I believe it was the antennas or some other appendage on that. So offhand, we're not expecting any significant change in the brightness of HST as it appears from the ground.
Steve Steislauf again from Florida today. First for Preston, the reaction wheel assembly that you're changing out, can you refresh my memory a bit? Has that been acting up since November, or is that still the only time it really?
It has not. No, it hasn't acted up adversely since the one time on November the 10th, where we got a telemetry dropout for about 7.5 minutes.
Okay, thank you. And also, when will the new arrays start charging the telescope?
Let's see. We probably won't use them to charge the batteries until after the PCU change. Let's see. Let me think here. I think we use that. We will do that as part of the functional test. So we'll do it for a short period of time before the PCU change out, and then after the PCU change out, we'll also do another test. But there is a period later on in the mission where we top off the batteries before we do deployment, and so that's another time when we do it. So there are several times during the course of the mission when the new solar arrays will be will be connected with the batteries.
Did you do any of the testing this morning during any of the functional tests this morning?
I don't believe that was done during the aliveness test. I think that occurs later on today with a functional test.
Okay, thanks. And my last question is for Brian Austin, and I'm just wondering if there's any chance the guys will be able to get out earlier tonight, if you think they'll be able to bump out about an hour or half hour early.
Oh, I think there's a very reasonable chance they can get out early. That's been their motivation leading up to the flight. That's what they've said that they're going to try to work toward each day. It just amounts to how the morning goes on board. There's a lot of folks on board, and as you may have seen in the TV today, it's a limited space there. So what you anticipate doing is one thing, and when you finally get up there and see how the logistics of everything are going to play out, it may not be fully available to them to get things going that early. But I know that's still in their plans, and we're still anticipating that and setting up our schedules accordingly just to be prepared for that. So I anticipate they'll probably try to get out a little earlier tomorrow.
This is Marcia Dunn of the AP with a quick question for Dana. Could you just sort of quickly review what will be involved in swapping out the reaction wheel? Is that a matter of connectors or a couple plugs?
Sure. There's 4 different connectors. 2 of them are heaters, and then there's 2 other larger connectors, and there are 3 keyway bolts. It's a pretty straightforward task.
And I guess for Preston, I haven't had a chance to, because of the way the telescope is turned, to see the side of the new array where all the new cells are. When I see that, can I expect it to be a pretty bright blue, as bright a blue as as bright a gold the other old ones are?
Yeah, I think that's fair to say.
Yes, it will be pretty.
It's Bill Harwood again, Preston. Could you refresh my memory? I know you've addressed this before. I just couldn't find it in my notes. On the RWA that you guys carried up, what was the issue that made you think about swapping that out before you launch? I just couldn't remember. I apologize.
What was the issue that made us want to replace the reaction wheel that's up there, or the issue that made us want to use a different reaction wheel on the mission? Could you say that again?
Yeah, I'm sorry. The one that was installed on the orbiter and y'all decided to swap it out before you launched, and then you went back and stuck with the original. I couldn't remember what the issue was that made you think about taking off the replacement or replacement
Right.
of replacement.
Right. Yeah, the one we've flown, the one that we took to orbit is serial number 1007. There was another one that we tested in parallel on the ground, 1009. There were a couple of issues. Number one, during an extreme cold soak test on 1007, the amount of current that the wheel motor needed in order to respond to a command to increase speed was higher than expected. So it appeared to be a little bit sluggish, and so that caused some initial concern. Later that was resolved with some experts that were familiar with the properties of a lubricant that's used in the wheel bearings. Another issue was 3 unexplained shutdowns of the wheel during the course of testing. That was later determined to be due to the ground support equipment that had a noise susceptibility problem. So in the final analysis, we felt there was no value added in taking the wheel 007 off out of the orbiter and replacing it with the 009 wheel.
Okay, I think they're done at the Kennedy Space Center. We'll wrap up here with Mark.
Thanks, Mark Carreau, Houston Chronicle. I have 2. One for Brian on the Freon loop. Is the situation changed, or is it still holding in?
No, it's holding in just fine.
Okay, thank you. The other one, I guess, is for Mr. Birch, probably. The telescope is asymmetric in regard to the solar rays. Now, I just wondered if, for some reason, you had to stop work at this point, or you couldn't put the other array on. Could you go to a situation where arrays of different types would still power the telescope?
Yep, we've thought about that long and hard. There are a couple of aspects. One is electrical compatibility, and the other concerns the effects due to the difference in inertias and due to the atmospheric drag at that altitude. The quick answer is we can fly in a mixed mode configuration and do science, and it's not adversely affected in terms of the scientific output of the observatory. So it'll fly and it'll work fine.
Okay, that's all the time we have for today's briefing. A couple of quick programming notes. The crew heads off to bed about noon Central, 1 o'clock Eastern. That will give us an opportunity to start showing all of the flight day highlights that you folks may have missed since the spacewalks are occurring overnight, so stay tuned to NASA television for that. The crew wakes up this evening at 7:52 Central, 8:52 p.m. Eastern Time, and the second spacewalk, as Brian mentioned, begins about 12:30 in the morning, although the crew could head out the hatch a little bit earlier, and that is Central Time. We'll be back tomorrow at the conclusion of the spacewalk as soon as everyone can assemble. That's currently scheduled for 7:30 Central, 8:30 tomorrow morning Eastern. So with that, I'll thank you guys for the briefing.